Assalamu alaikum students. I hope you all are doing good. Students, in the previous class we have studied chapter number 1, that is physical quantities and measurements. Today we'll start the next chapter, the second chapter of your books, that is kinematics. Before going into the topic, let's discuss today's objectives. So, the benchmarks that we will be covering in our today's lecture are Introduction to Kinematics, Rest and Motion, Types of Motion, Scalars and Vectors, Terms associated with motion, Graphical analysis of motion, Equations of motion, Motion of freely falling bodies, and in the end, the conclusion. So, what is basically kinematics? It is the branch of physics that deals with the study of motion of bodies, how they undergo different movements. But remember here that it does not deal with the causes of that movement. That will be discussed in our next chapter, dynamics. So let's see how many types of motion by different objects are shown. As everything naturally wants to move and change, in the world of mechanics, there are three basic types of motion. Translatory motion, which is further divided into three categories, that is linear, circular, and random motion. Second type is rotatory motion, and the third type of motion is vibratory motion. Let's identify these motions from our everyday life examples. So these are some of the objects showing various movements. The first example is showing the phenomena of vibratory motion. If you tie both sides of a stretched string or a rubber band with some fixed poles and then try to move it with your hand, you will notice that the string will move towards and away from its mean position, and such type of motion is called vibratory motion. Same is the case with the strings of guitar or a sitar. Or, same is the case in this example, known as oscillatory motion, that is, back and forth motion of this pendulum. In the second example, you can see that a person is trying to push a heavy mass from one point to another in a straight path. So, motion in straight line is termed as linear motion. For example, when you are moving a couch at your homes, or when you are moving a chair or a table in your classrooms, these all shows the phenomena of linear motion. Now this example is representing another type of motion. As you can see in this, that a boy is throwing a ball. This ball will move upward and then returns to the ground, but in a circular manner. Or this phenomena can also be noticed or observed by the motion of our earth. As the earth is showing two types of motion, that is rotation, due to which day and night happens, and revolution, due to which air comes. So this movement of earth around sun is in circular orbit. Such type of motion are called circular motion. But what is this second movement of the earth called, which causes day and nights to happen? As in this case, the earth is moving in a circular path but around itself. So, such type of motions are known as rotatory motion. As you can see such motion in this ceiling fan too. Think of some more example of these motion, then your concept will be more clear. So now, what are scalars and vectors? Or the difference between scalars or vectors? So, a scalar is a quantity that is fully described by a magnitude only. It is described by just a single number. Some examples of scalar quantities include speed, volume, mass, and time. For example, the speed of a car is a scalar quantity. For example, 10 meters per second, etc. Whereas a vector is a quantity that has both a magnitude and a direction. Vector quantities are important in the study of motion. Some examples of vector quantities include force, velocity, acceleration, and momentum. So these are the terms differentiated as scalars and vector quantities. Distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work are termed as scalar quantities, whereas displacement, velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag are termed as vector quantities. So now the question comes how we can represent the vector quantities. Vector have both magnitude and direction. Magnitude is always positive. Direction can be positive or negative. The two ways to represent vector quantities, the one is graphical, that is drawing arrows. Always draw tail to tip. Utilize NSEW coordinates, that is north, south, east, and west coordinates. And the second way to represent the vector quantities is algebraic way. For example, displacement is equals to 50 km southwest or 10 meter east. This is the magnitude and this is representing the direction of any object. The resultant. A resultant vector is a vector that is equal to the sum of two or more vectors. For example, vector A plus vector B is equals to a resultant vector, which is the product or the sum of these two vectors. Always draw resultant from tail of the first arrow to the tip of the last arrow, that is from the tail to the tip of the last arrow. And hence you will get a bigger resultant vector. As in this case, a force of 10 Newton acting in a southeasterly direction. Here is this vector showing the magnitude as well as the direction of the force. Now let's discuss different terms associated with motion. The first one is position. Position describes the location of a place or a point with respect to some reference point called the origin. Look at this example. Path taken by a car. The path is represented by a black line. So this line is the path taken by this car. To move from this origin to some point, for example C. So in order to find different positions attained by this car, we have to draw the position vectors represented by A, B, and C. So by the help of this, we will be able to find the position of the blue car, this blue car. Next terms are distance and displacement. Distance is the length of a path between 2 points. It is represented by capital S. So, as you can see in this diagram, this path or this larger path is known as the distance covered by any object to move from point A to point B. The second term is displacement, which is the shortest distance between 2 points, and it is represented by small d. So this is the displacement of this object which is moving from point A to point B. Whereas distance is a scalar quantity and displacement is a vector quantity. The next terms associated are speed and velocity. So, velocity is a vector quantity that signifies the magnitude of the rate of change of position and also the direction of an object's movement. What? The rate of change of position and the direction of an object's movement. That is, 20 meters per second is the magnitude, whereas north is the direction of this car. Whereas speed is a scalar quantity that signifies only the magnitude of the rate of change of an object's movement. For example, 25 meters per second is only a magnitude of this red car. So the formula of velocity is equals to distance divided by displacement divided by time, and speed can be calculated by the formula s divided by t, which is the distance divided by time. So the units of both the terms, that is velocity and speed, is meter per second. Meter represents the distance or the displacement, and second represents the time taken by the object. These two are the terms which are associated with the speed and velocity. That is the uniform speed, which is when body covers equal distance in equal intervals of time, and uniform velocity, when body covers equal displacement in equal intervals of time. Next term is acceleration. So, acceleration is increase in speed or change in the direction of an object, or rate of change of velocity is known as acceleration. So rate of change of velocity is represented as delta v in the formula of acceleration divided by t. Delta v is final velocity minus initial velocity of the object divided by the time taken. So the unit for the acceleration will be then meter per second square. As you can see in these two diagrams, the car is speeding up, and in this, the car is changing its direction from right, then to left, and then again to right. Now let's talk briefly about the types of acceleration. The first one is uniform acceleration. If an object's velocity is increasing at a constant rate, the rate of acceleration is constant. Or we can say that with every 1 second increase in time, the acceleration increases with the same value. Example, the acceleration increases 10 meters per second after every 5 seconds. The speed increases 10 meters per second after every 5 seconds. Then such type of motion will be termed as uniform acceleration of that object. Whereas non-uniform acceleration is if a car speeds up, then slows down, then speeds up. It does not have uniform acceleration, means at one time the acceleration or the speed of the body is increasing, then it has steady speed, then it undergoes deceleration, then again it undergoes the increasing acceleration, means the acceleration is not uniform. Or a random change occurs in acceleration of the body. The next type of acceleration is known as zero acceleration. It occurs when no force are acting on the object. As it is also stated in the Newton's first law of motion that an object at rest will remain at rest, or an object in motion will continue with constant speed and direction unless acted on by an unbalanced force which either increases the speed of an object or change the direction of the object. Other types of acceleration are negative and positive acceleration. Negative acceleration is anytime you see something slowing down. For example, a car braking is a common example, or a rolling ball that slows to a stop. So as the speed of the object is coming to zero, that's why such type of acceleration from some point or from some fixed speed, so such type of accelerations are known as negative acceleration. And positive acceleration is, for example, a bus or a car moving with increasing speed, or the takeoff by a plane as its initial velocity is 0 meter per second, and after some time it will have or in other words it may have attained some speed. Here comes the next topic, that is graphical analysis of motion. So, it is a pictorial way of representing information about relation between various quantities. It is more useful and helpful to represent the motion of objects using graphs. The terms distance and displacement are used interchangeably, or speed and velocity, when the motion is in a straight line. So there are two types or ways for representing information of various quantities. The first is known as distance time graph and the other is speed time graph. Let's discuss these two types or ways one by one. So, first graph shows a uniform speed of any object. The speed of an object is said to be constant if it covers equal distance in equal intervals of time, as we have discussed earlier. Its slope gives the speed of the object. The next graph is of non-uniform speed or a variable speed of an object. That is, when an object does not cover equal distance in equal interval of time, then its speed is not constant. The slope of the curve at any point can be found from the slope of the tangent at that point. You people must be aware of the famous catchwords that are: some people have curly black hairs to prove beauty. So, as here we have the perpendicular and the base, so we have to find the tangent in order to find the acceleration of the object. Moving in a non-uniform with a non-uniform speed. The third graph is about stationary objects or the objects that are at rest position. The distance moved by the object with time is 0. That is, the object is at rest. Thus, a horizontal line parallel to the time axis on a distance-time graph shows that speed of the object is 0. Or it has covered no distance with the gradual increase in time. The second way of graphical analysis of motion is speed time graph. The first graph is about a constant velocity of any object. That is, when the speed of an object is a constant with time, then the speed time graph will be a horizontal line parallel to the time axis along with this x-axis, representing a constant speed of the object. The next graph shows the movement of the objects having a uniform acceleration. Let the speed of an object be changing uniformly. In such a case, speed is changing at a constant rate. Thus, its speed time graph would be a straight line. A straight line means that the object is moving with uniform acceleration, and the slope of the line gives the magnitude of its acceleration. The third graph shows an irregular path or an irregular acceleration of an object. The area under this speed time graph represents the distance traveled by the object. If the motion is uniform, then the area can be calculated using appropriate formula for geometrical shapes represented by the graph, as this shape is like trapezium we use in geometrical problems. So by using that formula, we can find the velocity or the distance covered by this object. Our next topic is about equations of motions. There are basically three equations of motion for bodies moving with a uniform acceleration. These equations relate initial velocity, final velocity, acceleration, time, and distance covered by a moving body. But to simplify the derivation of these equations, we assume that the motion is along a straight line. So, hence we consider only the magnitude of displacement, velocities, and accelerations of any object. So, these equations are, first equation is Vf is equals to Vi plus At. Second is S is equals to Vit plus half At square. And the third is 2As is equals to Vf square minus Vi square. Whereas Vf is equals to a final velocity, Vi represents the initial velocity, T is for time, A is for acceleration, and S represents the distance or the displacement of the object. How we can derive these formulas? Let's see.
In this lesson, we shall derive some formulae related to motion. Say a vehicle is accelerating in a straight line with constant acceleration. As we saw in the last lesson, acceleration A is equal to change in velocity by time taken. That is delta V divided by T. Remember, Greek sign delta denotes change. So delta V means change in velocity. So delta V is equal to final velocity V minus initial velocity U. So A is equal to V minus U divided by T. From this equation we get V is equal to U plus A into T. Final velocity V given initial velocity U, acceleration A, and time taken T. Let's find another formula. If the object is traveling at a uniform acceleration, that is increase in speed is same for every time interval, then average velocity is equal to V plus U by 2. But we know average velocity is equal to displacement S by time taken T. So as left hand side looks same for both the equations, we can say V plus U by 2 is equal to S by T. We put the value of V is equal to U plus AT on the left hand side to remove V from the equation. So we get U plus AT plus U divided by 2 is equal to S by T. That is 2U plus AT by 2 is equal to S by T. T goes to other side, so this reduces to S equal to UT plus half AT square. We use this formula to find displacement S given initial velocity U, acceleration A, and time taken T. Now let us derive another formula. We know acceleration A is equal to V minus U by T, or T is equal to V minus U by A. And we know average velocity V plus U by 2 is equal to S by T. So taking T to the other side, we get V plus U by 2 into T is equal to S. And if we substitute T by V minus U by A that we got earlier, this becomes V plus U by 2 into V minus U by A is equal to S. 2 and A on the denominator goes to the other side. So it becomes V plus U into V minus U is equal to 2AS. From algebra we know x plus y into x minus y equal to x square minus y square. So it becomes V square minus U square equal to 2AS. This is another formula we can use if time taken is not given. So the three formulae are V is equal to U plus AT, S equal to UT plus half AT square, and V square minus U square equal to 2AS. So whenever we get a word problem or real life problem on motion, first we need to decide which formula is applicable based on which values we know. In the next lesson, we will solve.
Now students, let's solve a question that I've given you in your worksheets. Suppose the speed of a train increases from 40 kilometers per hour to 80 kilometers per hour in 10 seconds. Find distance covered by the train during this time. You are given with the hint that is 1 kilometer is equals to 1000 meters and 1 hour is equals to 3600 seconds, as you have to convert this kilometer per hour into meter per second. So now let's find the solution of this problem. Here we are given with the initial velocity as 40 km per hour and which we have to convert it to meter per second. So this is the conversion, 1000 divided by 3600, and then the answer will be multiplied with 40 and we'll get 11.11 meter per second. The final velocity is 80 km per hour, and here is the conversion of it, 1000 divided by 3600, and the answer will be multiplied with 80, and then we'll get the final velocity is 22.22 meter per second. So as they are asking us to find out the acceleration, find the distance. So before finding the distance, we have to find the acceleration. So acceleration is change in velocity, that is Vf minus Vi divided by the time taken. So putting the values, we'll get acceleration as 1.11 meter per second square. Now putting this value of acceleration in the equation of distance in order to get the distance of the train. So putting the values, we will get 166.6 meter, or in standard form 167 meter. It is the distance that the train has covered from point A to point B with initial velocity of 40 km per hour and the final velocity of 80 km per hour. Last but not the least topic of the motion is of motion of freely falling bodies. So the acceleration, in order to find the acceleration of the bodies, of such type of bodies, the acceleration is known as a gravitational acceleration, which is denoted by small g, and its value is equals to 10 meter per second square. As we have discussed earlier, that magnitude can never be negative, whereas the direction can be positive or negative. So positive acceleration when the body is falling down and negative acceleration when the body is moving up. As you can see in this example, weight is the only force acting on the object. This is a ball and this is an aeroplane. So according to the Newton's second law of motion, F is equals to ma, and if we want to find out the acceleration of this freely falling bodies, acceleration becomes F divided by m. As we have discussed that force is equals to weight, and weight is equals to mass into gravitational acceleration. So substituting the values of weight, we will get in the end acceleration is equals to gravity. So we can say that the mass of the object does not affect the motion, or the shape of the object does not affect the motion. All objects fall at the same rate in a vacuum, said by Galileo. An object is in free fall when it accelerates downwards only under the influence of gravity. Air resistance must be removed, which is an ideal case in the real world situation. The object is in free fall as soon as it is released, whether it is dropped, thrown down, or thrown upward. So this was basically the experiment conducted by Galileo. He dropped a pigeon feather and an apple in a vacuum place where no forces were acting on these objects except the force of gravity. Definitely, one can say that the apple will reach the surface earlier due to its high weight. But what Galileo noticed that both the objects hit the surface at the same time. By this, we conclude that all objects undergoing free fall having the same acceleration, regardless of shape or mass. So, in order to find the gravitational acceleration of the freely falling bodies, the equations will be like this. Vf is equals to Vi plus gt. Second equation will become S is equals to Vit plus half gt square. And the third equation will be 2gs is equals to Vf2 minus Vi2 or square. Whereas this g represents the gravitational acceleration of any body. As you can see in this diagram, this boy is trying to throw this ball upward. So as soon as he will throw the ball upwards, the initial velocity of this ball will be 0. And to find out the velocity of this object, we'll use this first equation. Vf is equals to Vi plus gt. As we have said earlier that the initial velocity of this ball is 0. So we only have g and t, the product of g and t. So placing the values, g is equals to 10 meter per second square and time is in 1 second. So the ball is thrown with 10 meter per second velocity. At the top, the velocity will be 0, as the ball does not free fall. But when it will be returned to the ground or the surface, again the initial velocity of this ball will becomes 0, and finding the velocity, substituting the values in the formula, we'll find that the final velocity of this ball will be 20 meter per second after 2 seconds. In order to find the distance or the height covered by this object, we'll use the formula, that is distance is equals to Vit plus half gt square. As we have said earlier that the initial velocity of the body is 0, so the product of initial velocity and time will become 0. We only have half gt square. Putting the values, we'll get the height, maximum height, or the distance covered by this ball as 20 meters. So students, let's sum up today's lecture. We have discussed about the rest and motion, types of motion, scalars and vectors, terms associated with motion, graphical analysis of motion, equations of motions, motion of freely falling bodies, and in the end, the conclusion which we are doing. I hope this chapter is pretty much clear to you. Take care and thank you.